So today we are going to mostly finish section 4.3. There might be a problem or two left on Monday or tomorrow that we'll wrap up. Tomorrow you have a unit circle quiz. And it's the diagram with the little bubbles, 32 little bubbles. You're filling them in with the angles, radian degree value, and then the ordered pair that goes along with it. And then I have a review worksheet of sections 4.1 through 4.3. So the hope is that you're continually just kind of refreshing yourself on this information, that you should be able to start that tomorrow in class. So 57, we have the cosine of crazy looking fishy. Looks like a fish, right?
Call it Jesus
Jesus fish,
fish.
it does look like a Jesus fish. Equals 1/3. What does the fishy represent? Julia? Yeah, that's your angle. So in algebra, we don't always use x. And we know there's y, we know there's z. Sometimes we solve for an m or a p. It doesn't always have to be an x. In trig, the angle, which is what that represents, doesn't always have to be theta. Generally, it's going to be some type of Greek letter in the alphabet, and that is an alpha. The Jesus fish is an alpha. So it means, though, the angle, just using a different letter. So you're going to see a beta, which is like a scripted B. Sometimes you'll see this, which is a phi symbol. So you're going to see different variables, different Greek letters representing angles. And it's always going to represent the angle. That's really where the variable is in trig. So the variable part, which is usually where we have our x, represents the angle. So if this says that the cosine of some angle is equal to 1/3, how could you start with a triangle? You're going to draw a triangle, because this is what the section 4.3 is a triangle. Julia?
You have the adjacent and the hypotenuse.
Yeah, cosine would be the adjacent and the hypotenuse. So you need to draw the triangle and pick where you want your angle to be. We can just pick it down here at the bottom. And then the adjacent is 1 and the hypotenuse is 3. And then Julia, to find the opposite side, we would, right. So 1 squared plus my other side squared equals 3 squared, which really means 3 squared is 9 minus 1 is 8. And then if you simplify that, Julia, your opposite side is
2 square roots of 2.
right, 2 square roots of 2. It was just a little different having a different, like, weird looking angle there. So the secant of that angle, well, if I know cosine is 1/3, the secant is just the reciprocal, so that's 3. Asher, what's the sine of the angle?
2 square root of 2.
Because that's opposite over hypotenuse. And then Asher, to find the cotangent,
Would be
1/2 square roots of 2 because it's cotangent. So adjacent over opposite. And then if we rationalize, we end up with the square root of 2. And then on the bottom, you have a 2. Multiply it by 2. That becomes a 4. So the last one is like the other weird notation, which we talked about on Friday. What does it mean if I have the sine of 90 degrees minus the angle? What is that called? There's a name for it. Yeah, this part here is saying complementary angles, and the sine talks about cofunctions. So this is asking you to find the cofunction for the sine. The sine is equal to what cofunction? Ashley? Cosine. So whatever cosine is, would be the sine of 90 degrees minus that angle. So this part here makes it a cofunction. So if the cosine is 1/3, then the sine of its complementary angle is also 1/3. Cofunctions are equal. So if I know this cosine, the sine's cofunction is also 1/3. Questions on that? Don't let the angle notation confuse you. It's just an angle, just a different letter. Questions? So if you look at page 27, I saw most of you had a diagram Get some blue water. A person is standing 200 yards from a river. So I have my river. You can have the river above, except then the water is going to crash on your head. So I put the river on the side. 200 yards. But instead of walking directly to the river, we need to make sure we get our 10,000 steps in. God bless you. So we're going to go 400 yards, still in a straight path, but that path can't go back. It has to go in some diagonal format to get to the 400 yards. The question says, find the angle between the path that you would take, the 400-yard path, and the river's edge. The hardest part is knowing where to draw the angle sometimes. So I need the angle that's between the path that my little guy is walking. So here's him walking. And the edge of the river. Where's that angle? Drew?
Would be like the top one.
Yeah, it's this top one. So the angle we're looking at is the top one because it has to connect with the edge of the river. The angle down here is 90 degrees. Oops. Forgot I didn't have a marker in my hand. And the angle over here would be in between both paths, whether I go straight or I go my diagonal path. But the one with the river is the one at the top. So Drew, if this is my angle, what two sides of the triangle do we have? And which function uses opposite and hypotenuse? Sine, yeah. So we're taking the sine of some angle and the opposite over the hypotenuse, which really Drew 200 over 400 is 1/2. So the question wants you to find the angle. So we're trying to figure out when is an angle equal to 1/2 for sine. Drew, when is the angle of a sine value of 1/2? 30 degrees. Remember, sine is y on the unit circle. So the y value on the unit circle is 1/2 for 30 degrees. The second, or the third question, I guess, down below, we have a flagpole. And it is a 40-foot flagpole. Cast a 30-foot shadow. Where's the shadow? Ashley? Where's the shadow?
Oh, this way.
Yeah, so if you have a shadow, which we don't hear, if I had a shadow, do I have a little shadow? Oh, I do. Yeah, it's behind me on the ground. So this shadow of our flagpole is going to be on the ground, and that's 30 feet. And then it says find the angle of elevation of the sun. So I know I have to make a triangle to the top of the flagpole. The angle of elevation. Where is that?
Wouldn't that be at the top by the flag?
That's what most people would think. It should be the one at the top because it's the angle that's up above. But when we do the angle of elevation, you have to do it from the person that would be viewing the shape. And Hannah, I say 95% of everybody that I see today has said on the top. So if there is a person standing here at the end of the shadow, and I know there isn't, but somebody has to be standing there to measure the angle. That angle of elevation would be from that person's viewpoint looking up to the sun, which you're not supposed to do, or looking up to the top of the flagpole. So it's actually the angle that's on the ground. If I was standing on the top of the flagpole and looking down, my head wouldn't be elevated. It's looking down. So the angle of elevation is the one that you are looking from your viewpoint up to the top of the flagpole or up to the sun. So Hannah, if we have this as our angle, what two sides do we have in our triangle?
We have the opposite
And the opposite and adjacent would go with
tangent.
tangent. So tangent of the angle is 40 over 30, which is really 4/3. Is 4/3 ever part of the ordered pair on the unit circle when we do a tangent? Tangent could be the square root of 3, it could be the square root of 3 over 3, it could be 1, it could be 0, but it's never 4 over 3. How would you find that angle using your calculator? True?
You did inverse
Yeah, so in the calculator, if you're trying to find an angle, we don't know the angle. That's what we're trying to find. Above the tangent is a little tangent -1. And you need to use that tangent -1, sine -1, when you're finding an angle. So if you don't know the angle and you're trying to find it, that would be the function that we're using in the calculator. So we have tangent -1, which is the inverse tangent, and then of 4/3. And that gives you about a 53-degree angle. Questions? So if you're trying to find an angle and it's not on the unit circle, then we use the inverse, depending if we have sine, cosine, or tangent. And the one above here, you can see like we could have done it for the previous problem as well. We kind of check our work. The sine inverse of 1/2 is equal to 30 degrees. Any questions? So in your packet, you have to flip backwards to page 25, I believe. So on Friday, we kind of just defined the fundamental trig identities, and we're going to just briefly talk about them today. It would not be something that would be a large portion of your test because this is contained all in Chapter 5. So Chapter 5 deals with all of these trig identities thoroughly. We're just going to do like a little brief intro to it right now. And then when we get to Chapter 5, we will focus more on what these identities are and kind of how they work. But an identity is essentially a property. It's a fact. So we can find information about trig and angles using the unit circle, making a triangle, or we can use these identities as well. So this is another way to find information about sine, cosine, tangent, and their 3 buddies. So the first question, a way that we can use the identities, is similar to number 1. So it says, given that the sine is 1/3 and the angle is an acute angle, so that means we're dealing with an angle that's less than 90 degrees. Find the remaining 6 trig functions using trig identities. So yes, we could draw the triangle because the sine is the opposite and the hypotenuse. So I could draw the triangle just like we did for question 57. But this is asking us to use the identities, which I have written on the sideboard, and you have at the top of your page. So if I know sine is 1/3, what other identity, or what other function, I should say, can we find quickly without doing any work, Asher? Because the cosecant is? Yeah, they're reciprocal functions. And that's what those first 6 problems are. The first 6 identities are the reciprocal identities. So without really doing any work, if I know sine, I can find its buddy. It's reciprocal, which is the cosecant. Right away, just flip it. So now I have 2 out of the 4. And we're going to try and find all the other ones, again, not by using a triangle, but by trying to use one of the identities on the side of the board or the top of your page. So we have sine and cosine, or sine and cosecant. But let's just focus on having the sine. So if you look at the identities above, what other identity can we try and use to find another trig function? Julia?
The one was sine squared plus cosine squared equals 1.
Yeah, so we have sine squared, that's what we have. So I have one function. I don't know cosine squared, but if you know one of them, we should be able to find the second one by using a little bit of substitution in algebra. So if we take sine squared plus cosine squared equals 1. So that's our identity. We know the sine. So if I use substitution, substitution says if you know something, you can replace it in for that function. So sine is 1/3, but it says sine squared. So Julia, what do you think we're going to do with sine squared? Yeah, square the whole thing. This is now like an algebra problem. I'm solving for cosine. Pretend that's x squared. Julia, 1/3 squared is 1/9. Again, pretend you're solving for x squared. So we're solving for cosine. We'd subtract a 9, which which is really 9 over 9. So 9 over 9 minus 1 over 9 is 8 over 9. How do you get the cosine by itself? Square root it. If it were x squared, we'd square root it. It's cosine squared. Anything squared, you have to take the square root of. So pretending that this is really separate, the square root of 8 and the square root of 9. I know the square root of 9 is 3. The square root of 8 is 2 square roots of 2. Usually we have a plus or minus when we're solving. However, it says that we have an acute angle, and an acute angle is in the first quadrant. So we're only worried about the positive cosine. So now in my list, I can add the cosine 2 square roots of 2 over 3. Which, yes, probably was the long way to solve it. But it's showing you that it can be solved using other information as well. It doesn't just have to be a triangle. So trig isn't all about triangles. Mostly about triangles, but we can find other things other ways. So now that we have cosine, what else can we find? Secant. So if I know cosine, the secant is just flipping it. So the 3 is on the top, the 2 square root of 2 is on the bottom. Rationalize it. Actually, what's the secant? Perfect. 3 times the square root of 2, that's on the top. The bottom is 2, and then the square root of 2 times the square root of 2 is another 2. So that becomes 4. All right, so now we have 4 of them done, but we still need to get tangent and cotangent. So how do you know, what have we been doing to find tangent and cotangent? How have we found them before? Julian?
Dividing the sine by the cosine.
Yeah, tangent is y over x, tangent is sine over cosine. That's the quotient identity. So the last thing we can do to get tangent would be to take sine divided by cosine. So the sine was a third. The cosine 2 square root of 2 over 3. Wipe out those 3's because they're both in the denominator, so cancel them out. And then we have a 1 and 2 square roots of 2. So, Julian, if we rationalize that, the tangent is?
Square root of 2 over 4.
Yeah. And you can find the cotangent the same way. So you can either say tangent is sine over cosine, so cotangent is cosine over sine. Or I can take my answer and take the reciprocal of it, however you choose to find the answer. So cotangent is cosine over sine, or it's the reciprocal of the tangent. Whatever you feel to kind of think about that. So here's cosine over sine for cotangent. These guys cancel, and I'm just left with 2 square roots of 2. And again, you could have found that multiple ways. So you could have also just flipped this. We could have flipped this answer here. A couple different ways we can find it. A lot of work. Triangle's way easier. Questions? So we are going to skip example 2 underneath. And we're also going to skip example 3. We're going to go to example 4. Example 4 is similar to the river problem that we were just doing in the application page. It wants you to find the values of theta, which is really the angle. So we're finding the values for an angle. It says in degrees between 0 and 90, so that means that if an angle is in the first quadrant, and in radians between 0 and pi over 2. So this is almost like working backwards in the unit circle. So we're so used to saying the sine of pi over 4 is this ordered pair. Now I have the cosine of some angle equals the square root of 2 over 2. So your goal is to find the angle. What is the angle equal to? So if I think on the unit circle, if I have the cosine is x on the unit circle. And if cosine is the square root of 2 over 2, sine is also square root of 2 over 2. Kaylin, what angle has that as an ordered pair? 45 degrees. So on the unit circle, if I have that ordered pair, we have a 45 degree angle. So it's like working backwards. You're thinking the opposite way. Kaylin, if you have a 45 degree angle, what is that as a radian? Pi over 4. So this time we're trying to find the angle instead of finding the ordered pair. On the worksheet I just passed back to you, you were trying to find the ordered pair and the 6 trig functions. So now this is kind of going backwards. So the second one says the sine of the square root of 3 over 2. Again, it has to be in the first quadrant. So I know I have to have an angle in the first quadrant. Sine is y. So if my y value is the square root of 3 over 2, the x value has to be 1/2. All right, so think on the unit circle. 1/2 square root of 3 over 2. What's the angle in the first quadrant? Asher? 60 degrees. Remember, it's 31, 22, 13. So 13 is with my 60 degree angle, or what, Asher, as a radian? Pi over 3. So some of the problems in your homework tonight, it's just getting you to think the opposite way. So now can you go back and forth? Can you have an angle and know the ordered pair? Or do you know the ordered pair that's also associated with the angle? And you're just working back and forth. Questions? The last 4 problems, which we probably will get to 2 of those 4, uses those identities again. And this is what a good bit of chapter 5 is like. So this is a little glimpse of it, but we're going to spend all of chapter 5 talking about this. Use the fundamental trig identities to transform one side of the equation. Transform means change. So that it is equal to the other side. So in a way, if you think back to those 2-column proofs that you did in geometry, no, we're not doing a 2-column proof, but it's kind of like that. We're going to start with one side of the equation, and our goal is to transform it or change it so that it's equal to the other. So right now, I have a 1 on the right side. My goal is to get the left side to also become 1, so that my last step says 1 equals 1. So that's the goal. We're going to do that by using identities and substitution, and also a little bit of algebra. So on the right side is a 1. We're going to change this left side so that it's also 1. But we're going to try and use an identity to do that. So right now it says sine times cosecant. Looking at the identities, and I have them up here, or you have them on the previous page, we're going to take out one of those 2 identities and replace it with what it's equal to. That's how substitution works. So you can take something out, and you can replace it with whatever happens to be equivalent to. Anybody have an idea of what we can use? Julian?
Could you replace sine with sine?
So the sine is equal to 1 over cosecant. And that's the first identity up here. So sine is 1 over cosecant. So substitution, the way substitution works, you take out the part that you're replacing. So I'm taking out sine. I'm going to replace it with this piece right here. If I had a y, I'd take out y and replace it with an expression that represented the y. So I'm going to take out the sine, replace it with 1 over cosecant. That's the substitution part. The rest stays the same. So there's still a cosecant. Oops, missed my C. And I'm just going to put that over 1. So took out sign, replaced it with what it's equal to. What happens when I have 1 over cosine times cosine over 1? Hannah?
Isn't it just cosine over cosine?
Yeah, that just becomes cosecant, not cosine.
Sorry.
No, it's my fault, not your fault. And Hannah, what is cosecant divided by cosecant? 1. So now, I have shown, or I have changed, transformed the one side to really be equal to the number 1. So we used an identity and substitution, and then a little bit of algebra. So my last statement, 1 is now equal to 1.
For A, could you also like divide whatever the value is?
No. So you're not allowed to do any moving, because then you're moving across the equal sign, and you're no longer showing that the left is exactly identical to the number 1. So that equal sign is almost like a barrier. We need to prove the left and change to be equal to that right. We're going to try to see if we can do this last one. We have 4 minutes. We'll see if we can do B. So in B, we have parentheses, 1 plus sign times 1 minus sign. We are going to transform it so that eventually it becomes cosine squared. So again, we're trying to change the left side to make it become cosine squared. What would you usually do in a problem algebraically if you have parentheses? Julian? You would multiply them together. This isn't any different than algebra. Just it has a sign in it instead of an X. So we're going to multiply these together, because that's what you would do if you have parentheses. So a little bit of FOILing. 1 times 1. 1 times negative sign. Negative sign times 1. And then sign times negative sign is like x times negative x. It becomes negative sign squared. Or it would be negative x squared. Mackenzie, what do you notice about this right here? Yeah, they cancel each other out. So now we have a 1 and we have a minus sign squared. So we did algebra. Now we're going to try and use substitution. I want you to substitute this number 1. If you look on the board, what is 1 equal to in one of those identities, Hannah?
Sine squared plus cosine squared.
So 1 is really equal to sine squared plus cosine squared. So substitution, taking away the 1, replacing it with whatever it's equal to. And then you still have that other piece. This negative sine squared is still in the problem. That was there originally. We just replaced the number 1. Hannah, what happens then?
Those signs cancel out.
Yeah, and we are left with that part we were trying to transform. Now it's just a cosine. Those are weird. They're a little different. It's a different way of thinking. This is logic. A lot of logical steps embedded with algebra. So there are 3 problems in your homework that are going to be similar to these. Again, that's all of chapter 5. Just a little insight. So we'll finish those other 2 problems up tomorrow. We'll take a little unit circle quiz, and then you'll have time to work on the review for sections 4.1 through 4.3.
Is that going to be on the whole unit circle?
The whole unit. Other questions?